injective, surjective, bijective functions. Injective, surjective and bijective functions. Injective function is 1-1. 1-to-1 or 1-1 function. Surjective function on two functions or on two mapping. Bijective functions 1-1 and onto. A function which is 1-1 and onto, both 1-1 and onto, is called a bijective function. I will give one example for that. In these cases, all students got some doubts, or someone has doubt. That is, how can we prove that whether it is onto or not? In that case, some doubts. I will clear this by one or two examples. First question is this. The function f from n to n defined by f of x equal to x square plus x plus 1. Prove that f is 1-to-1 but not onto. We will take two numbers. Let answer is this. Let x1 comma x2 belongs to n such that f of x1 equal to f of x2. This is the first step. x1, x2 belongs to n such that f of x1 equal to f of x2. That implies what? x1 square plus x1 plus 1 equal to x2 square plus x2 plus 1. In f of x, instead of x, you put x1 for x1 and f of x1. To get f of x2, put x equal to x2. That implies here this is x2 square. x1 square minus x2 square plus x1 minus x2. This 1 and 1 cut. Therefore, this is equal to 0. Then we want to take from this. This is x1 minus x2 into x1 plus x2 into x1 minus x2. And here is also 1x1 minus x2. So, x1 minus x2, we can take this as outside into x1 plus x2 from this step. That is x1 minus x2 into x1 plus x2 is x1 square minus x2 square, a plus b into a minus b identity. Then here plus 1, which is equal to 0. From this we take x1 minus x2 outside. That implies x1 minus x2 equal to 0, surely. But x1 plus x2 plus 1 not equal to 0 because x1 and x2 are two numbers and plus 1. And x1 plus x2 plus 1 not equal to 0. Therefore, from this x1 minus x2 equal to 0, x1 equal to x2. So when we take f of x1 equal to f of x2, we get x1 equal to x2. Therefore, f of x is 1 to 1 or injective. Here in this question, they give 1, 1. So you write 1, 1. If they denote it as injective, then you write injective itself. Not 1, 1, 1, 1, and again you write injective. So here fx is 1, 1. This is the step. In all functions, when f of x, some terms of x are given, you take like this. For x1, x2 belongs to n or z. What set they give, you write there, or for any two elements x1, x2. F of x1 equal to f of x2 implies you substitute the values of x1 in f of x for x of x1 and x2 instead of x, then we get x2. Then we can cut some terms or factorize, then we will reach in this answer. So f of x is 1, 1. If it is not equal to x2, then we write it is not 1, 1. Then to prove on to, there are two methods. First one is take this given function as y equal to that given function, then find the values of x in terms of y. But in all questions, we can't find like that. Then another method is there. If for the range is not equal to codomain, that is the another condition. Range is not equal to codomain, or for any value of this x, there is no x value, that is f of y equal to x. We want to get f of y equal to x. That is, for example, I will write here f of x equal to x square plus x plus 1 x plus 1, it is greater than or equal to 3. You know that because x belongs to n. So if you put 1, 1 plus 1 plus 1, 3. 1 plus 1 plus 1. So it is greater than 3 for all x. For all x belongs to n. That is no equal to, actually it is greater than 3. Okay, then that implies, what is the meaning of that? Domain, codomain. Then what we get? If we put x equal to 1, it is 3, isn't it? Then there is no value of 2, 1 in codomain. There is no values 1, 2 in codomain. What is the codomain? Here n to n. The function is from n to n, that is the second set is codomain. So in our answer, when we put the value for x, we didn't get 1 and 2 as the element. Therefore, for 1 and 2, we will not get the image. That is our codomain range. Starts from 3. That is not equal to n. Codomain. Codomain. Therefore, range is not equal to codomain. Range not equal to codomain n. N means natural numbers. In natural numbers, we want 1 and 2 also. But in our range, there is no numbers 1, 2. It starts from 3 itself. So, f is not on 2. To prove bijective function, bijective, that is 1, 1 and on 2. Question: let A equal to r minus set 3, b equal to r minus set 1, that f from a to b as f of x equal to x minus 2 by x minus 3, comma x belongs to a. Then show that f is bijective. Bijective means 1 1 and on 2. So answer, let x1 comma x2 belongs to a such that f of x1 equal to f of x2. That implies x1 minus 2 by x1 minus 3 equal to x2 minus 2 by x2 minus 3. That implies x1 minus 2 into x2 minus 3 equal to x2 minus 2 into x1 minus 3. That implies x1 x2 minus 3x1 minus 2x2 plus 6 equal to x1 x2 minus 3x2 minus 2x1 plus 6, that is expand it. Then here x1 x2 x1 x2 cut, 6 cut. Then we can collect the terms of x1 in one side, minus 3x1 plus 2x1 equal to minus 3x2 plus 2x2. That's equal to minus x1 equal to minus x2. That implies x1 equal to x2. Therefore, if f of x1 equal to f of x2 implies x1 equal to x2, therefore f of x is injective. That is 1 to 1, 1, 1. Then we want to prove that it is surjective, that is on to. For that, let we take y equal to f of x. That is y equal to x minus 2 by x minus 3. Then we find the value of x in terms of y. That is the process here. So cross multiply y into x minus 3 equal to x minus 2. That is xy minus 3y equal to x minus 2. xy minus x equal to minus 2 plus 3y. That's equal to 3y minus 2. From here you take x outside, x into y minus 1 equal to 3y minus 2. Therefore, x equal to 3y minus 2 by y minus 1. Then in our f of x, that is f of x, instead of x you put y, this 3y minus 2 by y minus 1. That's equal to, in x minus 2 you put x as 3y minus 2 by y minus 1 minus 2 by 3y minus 2 by y minus 1 minus 3. That's equal to 3y minus 2 into y minus 1 by 3y minus 2 minus 3 into y minus 1. Those denominators will be correct. So no need to write. Then 3y minus 2 minus 2y plus 2 by 3y minus 2 minus 3y plus 3. That's equal to minus 2 plus 2 here cut. So it becomes y. Here minus 3y plus 3y cut. It becomes 1. That's equal to y. Therefore, f of x is equal to y. This is the answer. So, if we get f of x, you substitute the values of that x in terms of y in the given function. If you reach in the answer y, then it is onto. If it is not equal to y, it is not onto. That is the test for onto. So, f of x equal to y. Therefore, f of x is surjective. That is onto. Therefore, f of x is 1, 1 and onto. That is bijective. X is bijective. This is the answer. So students, I gave some questions of relation and functions. If you, I hope you understood all these question and answers. Please, if you like it, please like it and subscribe it. Okay, thank you.